This is lesson 20 on rational equations. Remember, I mentioned in lesson 16 when we dealt with the cylinders that um, rational equations are different from polynomials because rational equations are dividing by a variable. So if you look at this notice and wonder, like this is a rational equation. And this one is a rational equation because we're dividing by a variable here. So these are not polynomials because we're dividing by variables. So we're starting to look at these kinds of equations now and also rational functions. So you can start by looking at this notice and wonder just to start thinking about rational equations and how they work. So as I go through this lesson, I'll ask you to pause periodically and try to work through something on your own, or you can work with some partners if you want to. But I'll ask you to pause and try to work through some stuff, and then you can unpause and resume the video. So you can go ahead and look through some of these things and see if you notice anything with these rational equations. So you can go ahead and pause here, or you can continue looking at rationalizing the price of t-shirts. Okay, so rationalizing the price of t-shirts. The school art club at a large high school is in charge of designing school t-shirts and getting them printed this year. A local business charges $35 to set up their t-shirt printing machine with the design and $4.25 in materials per t-shirt to print. So basically there's a $35 flat fee no matter how many t-shirts you're ordering, and then they also charge $4.25 per shirt. So the first question says create an equation to represent the average cost C of X in dollars per t-shirt if X t-shirts are printed by this business. So if you want to try to figure this out on your own, you can go ahead and pause. If you're not sure how to do this, I'll go ahead and explain the process here. So it wants us to find the average cost. And remember, to find the average of something, you need sort of like the total. So for example, if I was trying to find the average age of everyone in the classroom, I would add up all of your ages and then I would divide by the total number of people in the room. So if I'm trying to find the average cost, I need to find the total and divide by the number of shirts. So I'm trying to find the total cost and divide by the number of shirts. So first I have to figure out an expression to represent the total cost. So if we have a $35 flat fee and $4.25 per shirt, then the total cost is going to be $35 plus that $4.25 per shirt. So I'm going to multiply that $4.25 times X because X is representing our number of shirts. Remember, it says X t-shirt, which means X is our number of t-shirts. Okay, so if we want our average cost, C of X, then we want to take our total cost, 35 plus 425x, and we want to divide that by the number of t-shirts we're ordering. So if X is representing our number of t-shirts, then we just divide by X for our number of t-shirts. So then this is our expression to represent the average cost per shirt if X t-shirts are printed. Okay, number 2, what is the average cost per shirt to print 25 shirts or 100 shirts? I would like you to go ahead and pause here and try to figure out the answers to these really 2 questions. The average cost per shirt if you order 25 shirts and the average cost per shirt if you order 100 shirts. And you're going to use this equation. And also, while you're paused, look at this third question. What is the cheapest the average cost per the average cost per t-shirt will get. So what's the cheapest we can get that average cost? And explain or show your reasoning. So go ahead and think about those two questions. Work through this one. Number 3 will require a little bit of thinking about, like, if we want our average cost to be low, do we want to order more shirts or fewer shirts, and kind of go from there. So go ahead and pause and work through those two questions. Okay, so hopefully you paused already and worked through these questions, so I'll go through the answers now. So if we want to find the total cost for 25, or the average cost per shirt if we order 25 shirts, then we just plug in into this function 25 for x. So we're going to have 35 plus 425 times 25 divided by 25. And I'm going to have to get my calculator out for this. Let's see. Okay, I got $5.65. And then for 100 shirts, we just plug in 100. And I'm going to calculate that. And I got $4.60. Okay, what's the cheapest, the average cost per t-shirt? And explain or show your reasoning. So based on what we did here, it looks like if we order more shirts, our average cost is going to go down, right? So imagine if we order like a huge amount of shirts. If we order a huge amount of shirts, what is the cheapest? Like, what is going to be the average cost if we order a huge amount of shirts? So really, if we're paying $4.25 per shirt, it's never going to be less than $4.25 for the average cost. But then we also have this $35 flat fee, regardless of how many shirts we're ordering. But basically, the more shirts we order, the more this $35 gets broken up amongst all of the shirts. So the more we can divide it up, the better. And if we order like 1 million shirts, then this $35 gets divided up into 1 million pieces. So basically, the cheapest the average cost per t-shirt will get will be $4.25 plus a tiny amount. It will never actually be truly $4.25, but it will be really, really close. Okay. So let's go to number 4. How many shirts should be printed to have an average cost of $5 or less per shirt? You can go ahead and pause here and try to figure that out. I can also help you set up an equation if you're not sure how to do it. You could guess and check. Guess and check is never the ideal way to solve anything, but it is a way. So you can go ahead and pause if you want to, or you can just continue watching, and I'll explain how you would do this. So if we want the average cost to be $5, remember our expression for the average cost was 35 plus 425x over x. So if we want this average cost to be $5 or less, we can set this equal to $5. And we can see what number of shirts would get our average cost to exactly $5. And then we can go from there. So to solve this, the first thing I'm seeing is I'm dividing by x over here, and I really don't like that. So I want to get rid of this dividing by x. And generally, this is what you want to do first whenever you're solving a rational equation, is get rid of those denominators as much as you can. So I'm going to multiply by x so that I'm not dividing by x anymore. So that'll cancel out over here, and that'll mean that I'm now multiplying by x over here. So then I'll have, since these are going to cancel out, I'm going to have 35 plus 425x equals 5x. And then now we're just solving a regular linear equation. So I'm going to subtract the 425x from the 5x. I could subtract 5x from 425, but that'll get me negative, and then I'll still have to move some stuff over here. So I'm just going to subtract the 425x over here and subtract it over here too. So now I have 35 equals 0.75x. And then you should just divide by 0.75 to get rid of that 0.75. So then we just have 1x. And then that'll give us, I have to get my calculator out again here. Let's see, 35 divided by 0.75. That gives me x equals 46.67. But be careful, because we don't necessarily want to order 46.67 shirts. You can't order 46.67 shirts. So if we want the average cost to be $5 or less, remember, if we want the average cost to be less, we want to order more shirts. So we should round up here. So basically we want to order 47 shirts or more, because we want to find what would get us $5 or less. So 47 or more shirts would get that average cost of $5 or less. Okay, let's look at batting averages. Tyler is on a school baseball team, and he has had 24 base hits out of 110 at-bats this year. So what is his current batting average? So batting average is just your base hits divided by your at-bats. A base hit, it just means that it was a successful hit, like the person at bat hit the ball and ran to the bases. And then 110 at-bats is just how many times you were at bat, how many times you had a chance to get on a base, basically. So the current batting average would be 24 divided by 110. And batting averages are expressed as a decimal, so we'd want to figure out what that actually is. So I'm just going to take 24 divided by 110 on my calculator, and that gave me 0.218. Okay. So he wants his batting average, he wants to raise his batting average to 0.3. How many of the next consecutive at-bats need to be base hits to raise his batting average to 0.3? It says, write and solve an equation to describe this situation using x for the number of consecutive base hits. Be prepared to explain how you wrote your equation and each of your solving steps. So the first thing we got to do is write an equation we can solve. So if we want to raise the batting average to 0.3, that means we need more consecutive base hits. But if we add base hits, we're also going to be adding at-bats. So if you think you could solve this, go ahead and pause here and try to write that equation and solve it. If you're not sure how to do it still, I can guide you through it here. So if we are starting with 24 base hits out of 110 at-bats, remember, our batting average is just total base hits divided by total at-bats. And we want that to equal 0.3. But this doesn't equal 0.3. We want to see how many consecutive at-bats, how many more at-bats need to be base hits moving forward. So we've already had these 110 at-bats and we got 24 base hits from that. And we're trying to see how many more base hits we need moving forward in a row to get that batting average up to 3. So basically, if we're trying to raise our batting average, we're adding X base hits. And it's saying consecutive, which means we don't have any at-bats that don't result in a base hit in between. So we have X more base hits in a row. But if we have X more base hits, that means that we've had X more at-bats. Because if we don't have an at-bat, we don't have a chance to have a base hit. So we're trying to figure out what X would make this equal 0.3. So basically our equation is 24 plus X over 110 plus X equals 0.3. And then we just have to solve that. Now, if you think you can solve this, you can pause if you haven't yet. If you haven't solved it yet, you can go ahead and pause and try to solve it. If you're not sure how to solve it, go ahead and just follow along and I'll explain. So remember what I said up here with the t-shirts? You want to get rid of those denominators first. That's the first thing you should do. So I want to get rid of this denominator. I don't want to divide by 110 plus X. So if I'm dividing by something that I don't want to divide by, you just multiply by it to get rid of it. So multiply by 110 plus X on both sides. So then that'll cancel out over here. So I'll have 24 plus X equals 0.3 times 110 plus X. Now I want to distribute this. So 24 plus X equals, that'll be 33 plus X, plus 0.3X. And then I just need to solve from here. Now it's just solving a linear equation. That's not too difficult. So let's see. I don't want to get negative, so I'm going to subtract the 24 from the 33 rather than subtracting 33 on both sides, because then I would get a negative. It would work still if you did that, but I just don't want to deal with the negatives. So then I end up with X equals, let's see, that gives me 9 plus 0.3X. Then I can subtract the 0.3X. And I have 0.7X equals 9. And then divide by 0.7. And I get, let's see, and I get 12.85. Something's telling me that's not right, but maybe it is. No, I think that's right. So that means that if we need 12.85 more base hits to get to this batting average of 0.3, we really don't need 12.85. We need 13, because you can't have 12.85 base hits. So the answer to this is we need 13 more base hits. All right. Now, number 3, unfortunately, Tyler gets no base hits in his next three at-bats. Revise your equation and then calculate how many of his next consecutive at-bats need to be base hits to raise his batting average to .3. Be prepared to explain how you revised your equation and each of your solving steps. So basically, how this is going to work is now we have 3 more at-bats that were not base hits. So now our batting average that we're starting with, like we did up here, now it's 24 over 113. Because we've had 3 more at-bats, but no more base hits from those at-bats. So basically we just have the same equation, but with the 113 on the bottom instead of 110, and we just have to solve that if it equals .3. So go ahead and try to solve that on your own. Just go through the same process we did here. So I would really like you to pause and try to solve this on your own, and then you can resume the video when you think you've gotten the answer. Okay, so hopefully you've paused and tried to get the answer on your own. So let's go through what the answer should be. So if you multiply by 113 plus x on both sides, then it cancels out over here. We'll have 24 plus x equals, let's see what 0.3 times 113 is. 33.9. Okay, and then I'm going to subtract the 24 from both sides, so I get x equals, let's see, that'll be 9.9 plus 0.3x. And then subtract 0.3x. So we get 0.7 x equals 9.9, then divide by 0.7, and you will get now I got 14. So I got 14.14, but you can't have 14.14 base hits. So you want to round that to 15.